Hey there, welcome. So, this is it. Here we start a journey towards learning assembly language. So, there is so much to say. So many things we need to learn during this course. And in the beginning, it can be very, very overwhelming. There's like a million things we need to talk about. So what I'm going to do, I'm going to take this very step by step. So I'm not going to throw everything at you from the very beginning. I'm going to try my best to take this, just like a ladder. You take one step at a time. And there's one thing that I just want to get out of the way right now. Things can get really confusing. There are many new terms and many things to remember. And things can get really confusing. So, let's use the correct terms from the very beginning. So if you talk to people who programmed in the assembly language in the 80s, 70s and 80s, you'll often hear people say they are programming in assembler. They are going to use assembler to program something. They actually call the programming language itself assembler. And technically, that's not correct. The language itself is called assembly language. So why is this important? Well, it's important for us here at the beginning, because we want to avoid any kind of unnecessary confusion. The thing is, we are going to use something called an assembler. That's a tiny little piece of software that's going to be a tool for us to convert our code into binary code. So let's not confuse assembler and assembly. So the programming language itself is called assembly language. So let's just get that correct from the very beginning to avoid any sort of confusion. Alright, now with that out of the way, let's start by looking at what assembly language isn't. So, what we have right here is a Windows XP machine with Visual Basic 6. So, I'm just going to make a quick application here. So, I'm just going to click this button, drag this button like this. I'm just going to give it a name, like that. And I want something to happen when I click this button. So I just double click here and I write a simple command here, msg box and hello. So now I'm going to run this application. Just press this play button and here we go. Here's my application. I have a button, I click this button and something happens. I get this little message. So, what's going on? Why am I showing you this? Well, this is a very good example of what assembly language is not. Let's take a look at one more example. This, the Commodore 64 screen. So, maybe you have programmed in BASIC yourself in the 80s. But let me just write a quick basic program here. So I'm just going to write line 10. I say x equals x plus, plus 1. X plus 1. And line 20, print x. Line 30, go to 10. Like that. This is a basic program in Commodore 64. So now I'm just going to run this. There we have a little counter. Alright, so what's going on? Why am I showing you Windows XP with Visual Basic or even Commodore 64 with regular BASIC? Well, like I said, this is what assembly language, this is almost the opposite of assembly language. So what do I mean? Well, first of all, this Visual Basic program this is a very user-friendly interface. So here, for example, I can just drag a button if I want a button. If I want something to happen, I just double click, write a simple command in English here, and yeah, really simple. Now, for assembly language, it's so totally different. We don't have this. We don't have a graphical user interface. We don't even have this, the Commodore 64 screen. So here we have print, we have goto, we have English words. We have nothing like that in assembly language. So let's take a look at what assembly language actually is. This is assembly language. So what do we have here? Do we have a graphical user interface? Well, apart from the editor that we're using right here, we don't have any graphical user interface. So do we have any English commands like print, go to, whatever? No. We have this: LDA, STA, and just a bunch of numbers. So my point here with showing you all of this is that assembly language is so different from other kinds of programming languages, because we are programming at a very low level, and we're going to program directly towards the hardware, and that's probably the most important part. So we can't use these English words, commands with English words. We only have these 3-letter commands, which are called opcodes, and those are the things we need to work with. So basically, you just have a lot of 3-letter commands and a lot of numbers. And we need to make sense of that. We need to give everything that we do a meaning. So, for example, I have my assembly code here, and when I run it, I get this. This is a Commodore 64 screen, and this little assembly program that I made right here makes the Commodore 64 say hello C64 up here. So by doing this, I can get this result. So this is my Commodore 64C that I got for Christmas in 1986. And yes, it still works. So this is what it looks like on the inside. So we're just gonna take a quick look. We're not gonna look at every component in detail, but we need to look at the essential components here. So the most important one is, of course, the CPU. This one right here. It's a 6510 CPU. So it's not a 6502, it's a 6510, but it's almost the same as the 6502. Just a few small differences. And let's not go into detail about that right now. But since we're using a 6510 CPU, which is in the 6502 family, basically the programming language is the same as if you would program for an NES, for example, which also uses the 6502. So we have the 6510 CPU here, and if you look down here, we have a RAM. These two chips here, these have 64 kilobyte of RAM. That's the RAM that we have available for us. So yeah, let's not go too much into detail right now, because we are going to talk a lot about the RAM later on. So we have a CPU, we have a RAM, we have something up here called SID or SID. So this is the SID chip. Now the SID chip on the Commodore 64 makes sound effects and music. So all sounds you hear from the Commodore 64 comes from this chip right here. Now we will not be programming directly for the SID chip. Now we will be using pre-written music. So in one way we will be using this, but we're not going to program a music routine, for example. So a SID chip. But this one right here, this is the VIC-2 chip. Now the VIC-2 chip That's the graphics chip for the Commodore 64. So this is basically, well, these two chips are probably one of the main reasons that the Commodore 64 was so famous, because this, at the time, this was an amazing graphics chip and this was an amazing sound chip. But this chip we will be using a lot. So these are the main components that we will be using for our programming. But right now we need to take a closer look at this thing, the CPU. After that we need to take a look at the RAM. But let's start with the CPU. So let's take a look at how the CPU works. Just a brief overview. So we briefly looked at this code a moment ago. So in just a little while, let's see how that actually works in the computer. But right now we have the 6510 CPU over here. Then we have a RAM over here. Now the 6510 has several components inside. So the main three things we need to worry about is the accumulator, the X register and the Y register. Now I'll go into detail about each of those in just a moment. But we have a CPU and we have a RAM. Now as you can see here, the RAM consists of several, it's like a table almost. And every cell here has its own address. Now the address starts at 0000. So this is just a random selection taken from the RAM, just for this example. Again, we're going to come back to that. So these two are the main components, basically, of any computer. And the Commodore 64 is no different. So the 6510, the CPU, the RAM need to communicate all the time. So if we now take a little look at our code from earlier. Now I didn't show you exactly what was going on here. I just showed you that this was assembly code. But we have something here called LDA. Now LDA stands for load accumulator. And there's a hashtag here and the number 8. So what we're saying right here, we're saying load the accumulator with the number 8. So that means that when we write this in our code, we are loading the number 8 inside the CPU. So this little area inside the CPU called the accumulator, that's where we're loading our number 8 right now. So the 6510 has 3 little areas like that where we can have numbers. Now right now at the very beginning, this is probably really foreign, maybe even hard to understand. Like, what's going on? Why do you want numbers thrown into the CPU? But of course, as I said, we need to give everything meaning, and right now we just need to cover the very basics of how this works. So what you would do like this, you load A into the accumulator. If you'll take a look at the very next line here, it says STA. Now that's store accumulator. Now this command stores whatever is inside the accumulator, and it stores that at the specified memory address. And in this case, that memory address is 0400. Now we have a $sign in front of this, which means that this is a hexadecimal number. Now we are going to take a look at numbering systems in just a little later, not right now. But anyway, so basically what we're doing here, loading 8 into here, and when we're storing accumulator, we're storing it to a memory address. Now 0400, I don't have that in this picture right here. But let's take a look at something similar. So, as I said, we're going to look at numbering systems. So don't worry about all these zeros and ones. This is just a binary number. But the way this works is that we're loading something into the accumulator, and once we have done that, we can store that into a memory address. So here we are loading 01000 blah 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 into the accumulator, and then we're storing that to memory address 2004. So basically just copying what's in the accumulator into a specified memory address. Now, what's nice about this picture is that it really shows us that this is an 8-bit CPU. So we are only dealing with numbers that have 8 bits. Now, again, we are going to look at number systems just a little while, but take a look at this. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bits in 1 byte, and that's the largest unit that our computer can handle right now. So what does that mean? Well, let's open up our calculator, and let's just type in these zeros and ones here. 0, let's see here, 0, 1, 0, 0, 1, 1, like that. So this number is actually 77. But again, let's wait with that just a little while. Because my point here was that we have zeros and ones, and if I set all of these zeros to 1, we get this number, 255. So 255, that's the largest number that we can use in our 8-bit CPU. That means that if we at some point need to use a bigger number, let's say you're making a game and you want a score that's several thousand, then we need to do some clever programming to make that work. But we can never in our code use a number that's bigger than 255. It's like that for every single 8-bit CPU. This is the biggest number that this CPU can handle at one given time. So we can never load 256 in here, for example. That doesn't work on an 8-bit system. So, alright, so we have our CPU, we're loading something into the CPU, and we're storing it into RAM. Great. Now let's take a closer look at the CPU, because right now we can see that there are other things there as well, and I said that we could store stuff in there as well. Well, let's take a look at what the CPU actually looks like. So this is what the 6510 CPU, how it's set up. We have our accumulator up here. We have our X register and we have our Y register. These 3 areas are the areas where we can load stuff into. These other areas are not something that we are going to load values into like that. These ones are handled by the system itself. So if this is your first time learning assembly language, if you think that this is really confusing at this time, look, I get it. When I started learning a few years ago, this was like black magic to me. But for now, it's just important to know that we have these different parts of the CPU, and we will be using the accumulator, the X register, and the Y register a lot in our code. Now, the stack pointer, that's a whole topic in and of itself, so we need to wait about that. Now, the program counter, it's almost too early to talk about that as well. But let me just say that the program counter, that's the thing in the CPU that keeps track of where it is in the code at any given time. So if you didn't have the program counter, the CPU wouldn't know where to go next. So it's a really important one. We're going to come back to that. Now, the last one here is called CPU flags. Again, it's almost like it's a little too early because we haven't talked about binary systems yet or anything like that. But there's 1 byte in here. And like I said, 1 byte is 8 bits. So we have 8 bits here. And any one of these can only be a 0 or a 1. So we can think about these like switches. 0 is off, 1 is on. And it's like that in the CPU flags as well. But let's wait before we go into detail about the CPU flags. So the main point here is that this is what the 6510 CPU looks like on the inside. And we will be using these 3 a lot. Alright, let's just come back to the CPU when we start coding. So we have a little bit more to work with. So LDA, SDA, load accumulator, store accumulator. And of course our memory addresses, which is what we'll be looking at next.